Hi everyone, I hope you're doing well today and have enough power to warm up a little bit with the Helpdesks, LLM and the stuff. So, my name is Maxim, I'm an AI&ML engineer in DataArt and have been working in DataArt for almost 5 years. Okay, and the topic of my today's discussion is streamlining Helpdesk with RAG and LLMs. So, a few words about DataArt. So it's an outsourced company, quite big enough. So we have more than 5,000 colleagues, and here is the nice picture presenting where we have offices, like some of them are sales ones, some of them for the developers, but our colleagues working almost from all over the world and remotely, even without offices. It's not presented in this nice picture. Also, some numbers. I have no idea what is, like some abbreviations here, but you can take a look. And as far as DataArt, a big company, we're not working with the AI only, with the machine learning engineering only. We're working with a lot of industries like travel, finance, healthcare, and so on. But we have labs in our company, and one of them is AI Lab, where I'm working. We do lots of stuff in data science, AI, generative AI, machine learning, and so on. That's like part of what we are actually doing. I think there are more and more opportunities because AI is really impressive now. And let's move next. Global Helpdesk project. What's it actually? And why do we start developing the Helpdesk? In the beginning of 2023, we found out that inside the company we have quite strange and weird system how can we approach help internally. For example, if you need to fix your VPN connection or your laptop is not working properly, what should you do? And the system was like presented here. So we have lots of mailing lists. You need to remember them or like have a knowledge how to find them on Confluence pages. And moreover, there are more problems that you need to know where to find it. You need to know what requests which mailing list is responsible for. You can write to admins that you have a problem with the laptop, and they say, okay, it's not ticket for us. You need to go to your local HR and close the ticket. And you don't reach any help. The ticket would not be raised. It would not be tracked. No centralized system for tickets in general. Colleagues just open up their email where they want, no 24/7 support. Nothing's happening. You just need to do everything manually. Also, it's kind of wasting time of valuable colleagues because even the head of accountant may answer some simple questions like where is the date when the salary came to my card in bank account, and the head of accounting needs to read this in the email, answer you, but it's definitely maybe automated and so on. And that's why we decided, okay, we should do something with that. And here's the initial idea. ChatGPT was introduced already, and we know that we can use something like that, but there was still no APIs. We need to do some tricks to retrieve the information from LLM at that time. No good frameworks. The LLM chain exist, but it was not the best solution. And we decided, okay, what we can do? So our company using Microsoft as a big partner for long years, and all our internal system based on the Microsoft products, for example, Microsoft Teams, like SharePoint and so on. That's why we decided, okay, everyone is using Teams. We need to do Teams bot, where everyone can send their requests, get some automated information or raise a ticket anywhere, like in any help desk, and don't know and don't have a mess in their heads, like, okay, what was I supposed to do in this situation? and it should be RAG-based. We thought that, okay, we can take some information from Confluence, from Wiki, grab it into some vector database, perform the vector search, and then send this information to the OpenAI. And after a while, we will provide answer to the user. Seems pretty interesting. Like, get rid of all the emails, have Jira Service Management as a ticketing system. Okay, what can go wrong here? Yeah, I believe if you have ever developed a RAG system, you know what can go wrong. After the first released version, which happens after half a year of development, or maybe a little bit less, maybe 4 months of the development, we found some issues with our solution. So there are two types that we find out. The first one is general, and the second one is the RAG connected. It's like the main topic. General is just presented because there was not only issues with the RAG implementation. And some of them also was fixed, some of them just can't be fixed because of the user's behavior. Like some of the users said, okay, we don't want to use this creepy AI new technologies. We want to send emails as 20 years ago and still reach the help because we are doing it. Like, well, why should we use these Teams and AI? We don't want to do it. We found lots of conflict information on our Confluence because no one is responsible for updating them. Many pages. The same is on the wiki. And when we are performing the RAG, we find out that the model can retrieve conflict information during the one search, and the LLM can resolve which one is top priority, which one is correct, and it's kind of a crucial issue, especially if user asks for some legal questions or trying to ask, can you provide me this document templates in the last version, but the LLM don't know which version is last, just have several chunks of the text, no priority, nothing to do with that. Also, regarding the user behaviors, one of the issues was that users trying to find the information as they are usually doing on Confluence or on Wiki. Just write down one word, VPN, and expecting that every article that we have on Confluence where VPN is mentioned, we will provide them. But that's not how the vector search working. We had also high expectations because AI was on hype, and we need to do something with that. This RAG system was designed only to work with Confluence and Wiki, but the users ask, okay, what's my birthday? What is the date of the birthday of this colleague? And the user expecting that, okay, that's the system, it can do everything, but that's actually not the case because under the hood it has limited information, limited knowledge base. So, also we find out that table-based contents are not correctly interpreted by LLM, and some contacts tables, holiday tables, and their offices addresses also was not parsed correctly by the LLM. Some of the answers we find out that must be dependent on the user location because we have lots of the locations, and user may ask, okay, public holidays in my location. And we need to provide the information about the user location, not in general for the whole DataArt offices. And for sure, LLM hallucination. And we find out that everything that is not provided in the context, not mentioned in the prompt, will be hallucinated, 100%. If the model can provide and can generate the URL, for example, even the main URL of the Confluence, the model will generate it. Be sure, you need to validate everything. So what was done to improve our initial idea and the RAG system? First of all, working with the query. So as far as I said that users may type only one word and nothing more, no more context to search, we need to adapt our system. And moreover, we find out that in some cases, users just want to talk with the LLM without searching anything, just about the weather, about their recipes, how to prepare foods, and so on. And for some cases, for sure, we need to create tickets to minimize and to increase, to minimize issues and to improve the performance. We start classifying all the queries that come to our Teams bot to three labels: ticket, information, and other. Other is supposed to just talk with the LLM without any additional context, as it is. Information is supposed to find some useful information on corporate knowledge base, and ticket just for creating a new ticket to the appropriate help desk with automated classification. We start also rephrasing the query. Like there are a few examples. Because for the probably the most funniest example is the second one. All our policies internal are saying public holidays, but not working days. And when user trying to find not working days, we are not capable enough during the vector search to find these policies. Some of them are more specific, some of them are less specific, these rephrasings, but we still do it. Also, as far as AI can talk to you in any language, and user actively were trying to do it. And we also decided to translate all the query from the local languages to English, because most of the information presented in the knowledge base are in English, but not all of them. Some of them are still presented in the local languages. And we decided, okay, we can do some parallel requests. And the last but not least, cleaning characters. We found out that even just a question mark at the end of the query may significantly change the whole LM output, despite the fact that we provided the same context, but it still can do it. Even if we set temperature to 0, even if we set random seed to some state like 42 as usual, but it still can produce different outputs. What else? Improving the search. As I said, just usual vectors are not capable enough. So we find out that, okay, we can actually use not one vector for the search, but a few of them. The second one, here is just the names of the models, but it can be any model. One of them is for the full dense search, usual vector search. In our case, it must be multilingual, but in your case, it might be any other model. And we also find out that it's more and more cheaper to use some local embeddings model rather than rely on Azure API or any other APIs. And the sparse vector, it's actually keyword-based search, where you have like lots of ones and zeros in the vector, and it's super helpful to search in one-word cases. So as I mentioned, we do lots of stuff with the rephrasing query from the previous slide, so translating query, we clean it, and we do it everything in parallel. So we are sending from like 4 up to 8 requests in parallel to the vector base and give lots of information back, lots of chunks back. After it, we find out that our context is not infinity, it's limited a little bit, as all context for the LLMs. And we try to use classical reranking models to just rerank everything, but find out that it takes like fortune, a minute or maybe 2 minutes. User would not wait this time to rerank all the results, and we use just simple function to rerun the results, to get rid of the irrelevant ones, and rank all the queries that we used with location, without location, rephrased one, non-rephrased one, English, local language, and so on. Also, we found out that some questions are frequently asked, and it should be some concrete answer for the concrete question, especially when we're talking about sensitive questions like legal ones, and if user asks just to provide this template, we need to provide the link to this template, and that's it. But instead of hard coding the answer for the question into the vector database, we just map some popular queries to the link, where we know that this one link to the Confluence is the only way to answer this question, is the only correct way to answer this question. And we are still relying on the LLM, but as for the search, we just found, we found some mapped links to the question using the vector search and parallel queries. Then we can use only the information stored in our vector database connected to this link only. Improving the vector database itself. We also quite rapidly find out that the way how we're storing our chunks, our data is not optimal. It's not including all the context that user even see on Confluence, like title of the article, like parent pages, and so on. Confluence namespace also might be useful enough. And moreover, we are not only storing all of this in the vector databases as a metadata, but we also include most of the information into the chunk itself. And the chunks, the way how we work with the chunks of the data also was reworked. We find out that if we are following, not just splitting by some limit of the size, like 1,000 tokens or half of 1,000 tokens, that just splitting by the titles and the headings inside the articles, it's even better in terms of the search and in terms of the logic. But for each chunk, we're adding additional keywords, labels, and stuff like that. Also, the last very important point on the left side in the slide is that we are now extracting all the URLs from the page. As far as you might remember, I said that everything that is out of the context of the LLM and out of the prompt that we configured might be hallucinated. And even the links hallucination is the most painful for the users. You're just providing the LLM output, user click the link and find out, page not exist. And immediately write the feedback, so your bot is not working, do something with that. So that's why we need some source of truth, some set of the links that can be provided. So if we see that some other links provided in the output, we just trying to regenerate it. And as I also said, that table information and table structured information are not the best input for the LLMs, and some really important information for us, like locations, holidays, contracts, office addresses, we stored separately in PostgreSQL, just separate code that parse the Confluence page with the table and store it as a SQL table. And now it's called AI agents, but when we are doing it, it was not called like that. We just find out that, we can create simple SQL queries to get the correct information instead of trying to find the appropriate chunk of the table. So, and the tips regarding the LLM itself, we just significantly improved our prompts, and we even created auto tests to evaluate the prompts. We had a list or a data set of prepared answers, and we used some techniques like statistical one and non-statistical one, using the LLM itself to evaluate that the new prompt and the new answer from the LLM are follow what we have prepared. I've already mentioned that we are using function calling, but now it's called AI agents to use the table data with the LLMs. Also, in one of the articles that we find out that, and also our research proves that we can not only get the chunks that we find out during the vector search or keyword search, that we can also retrieve the neighbors of the chunks. And the metadata that we are storing in the previous step in the vector database, like the IDs of the chunks, are really helpful. We can have more chunks, rerank them, and then provides more appropriate answer for the user. Also, setting temperature to 0, fixed random seed, everything helps to produce the reproducible output. Like the users mostly expecting that for the same inputs they will have the same answer. But that's not how the LLM designed in general. So I mentioned that we start using the classification of the user queries, like to tickets, information, and other, and to have the stable results. So just temperature and fixed random seed is not helping enough. Because for the 99% cases, you see that, okay, that was classified as ticket, but on the 100th attempt, you find out that it classified now as information without no reason, no prompt changed, nothing changed, but the LLM decided to do it in a different way. And that's why we run in parallel these classification requests, and after it gathering it with the separate prompt, just picking the majority result, like two tickets, one information, we're picking ticket as a category for our query. Also, prompts structured as a markdown format. It's more suitable to read, and it's better for the model to have some structured instructions rather than just plain text. And this set of links, I've already mentioned that now we are validating all the inputs, all the URLs and emails provided to the user. We are just comparing what we found in our context, in our chunks, and comparing all the links that model was providing. That if we see something is not correct, we see some hallucinated link, imaginary ones, we are generating the answer. If after the several retries, we still can generate the answer without hallucinated link, we are providing just the top links that we found by using some hard-coded message on the user language, just classifying the language using the same technique, and providing, okay, we found out something, because we all the time we can find something on our vector database, but the LLM, if it's not like seems like correct search for the answer to the user, it can answer just, I'm sorry, I can't answer, I didn't find anything. And the user also start typing the feedback, your system is not working, it can't find the information. And we decided, okay, that's not the best really way to respond to the users. And that's why top 10 links is working even better. If it's some of the links, maybe even 8 out of 10 is not relevant enough, the users still can do it by themselves. Okay, the one or the top 2 is okay for me. I don't even need the answer from the LLM. So, and you remember the picture that I showed before with the initial, the small one. This one is not even readable enough. That it's supposed to. You don't need to read it. It's just to show you the volume of the work that was done to improve the overall work system. And what's the current state of the project? So as far as I mentioned that it was started in 2023, now it's in a production and it's working. Here is our main workflow. Now we have the service desk, and we are now supporting the emails. The user can communicate with the Teams bots, service desk, email doesn't really matter, we still create ticket, we still can provide the answers, and it's even synchronized. So if you created a ticket in the service desk portal, you would get notification to the Teams bot and to your Exchange and so on. We are using Azure to host all of the system. I have lots of stuff there, like the synchronization, the separate indexer that is indexing every day, updates on Confluence, and yeah, that's actually working. And this is not the concept, but it's more or less developed architecture. Also, there's one thing that's we created a reporting system with the user feedbacks and so on, designed in Power BI. We're also using the data about the user from the entry ID. We also created a separate web widget to be integrated in the other corporate systems, so it's also still in development, but for the some resources it's working. So as for the vector database, we used Quadrant, quite useful one. It can be deployed locally, or you can use it locally from the Docker container, so we are not paying for the vendors, to vendors for these solutions. I think that's mainly it in terms of the diagram. And the tech stack that we used, that's mostly connected to also Microsoft, but for sure Python is the main language for this solution, except for the Teams bot, we use .NET framework to develop our Teams bot. For our service, it's kind of the front end. So, and here is some real statistics starting from the 2023 and up to the end of the April. So, yes, you can see the users still using quite a lot emails, but some of the requests are automated, and we are satisfied enough with the number of automated tickets, because before the system was released, as I said, nothing was automated at all. Like everything should be answered by human. And also I've prepared a small video. So with the demonstration of how the system works actually. So it's the production version, and I start with the creating ticket. So that's my ticket that I created for this presentation, as you seen like seconds ago, because in our rules we need to send this presentation to designers that will check that presentation is following the corporate templates, has appropriate fonts and so on. And I just have sent this presentation. All these requirements was provided in advance, and I will mention them and said just, okay, create ticket for me. And the bot done it, and also you can see that, okay, your file is too large, we can't handle it. But nothing to worry about, you can add it after the ticket was created. And even the bot asks me, okay, is your presentation following this corporate template? And I answered yes, because I just downloaded it from there. And it's creating a ticket for me. Okay, I hope video is playing right now. Yeah. And it's creating a ticket to the Jira service management. With all the description that I provide is with metadata. You can even see that this was automatically classified to the designer helpdesks, which was the request, the idea of the request, and providing me the ticketing number and providing me the link. You can even provide help us to improve this, like all the feedbacks that user sends to us, and you can leverage how accurately the classification was performed and so on. And you can click the link. Yeah, the feedback was recorded, great. And you can click the link, and the Jira service management will be opened. So here is my ticket that was created. You can see that my comments where I'm adding the presentation. It includes all the information about me, like Maxim Polyakov, creator, and so on. Everything's happening automatically. And here is the whole information about me, like my location, Larnaca, Cyprus, and so on, like my title and the stuff like that. And we can go back. And this the most interesting part for each ticket, because we can only have one chat with the bot, only one-to-one, and for the tickets we're creating the separate chats. bot is not presented here. Only the ticket participants, the creator, the assignee, and other participants like approvers, for example, in some legal cases, are presented in this chat. And you can find the same links to the service desk. You can find all the information regarding the ticket. The same is in the Jira. As I said, everything synchronized. Here I've added in this chat the link and some colleagues from support just saying that, okay, it will be reviewed and just see that everything is fine and the ticket was closed. So you have seen the presentation, it was really closed, everything's fine. So, okay, and here I just wanted to find some email and form for our US office because I was applying for the United States visa, and the bot really didn't found some information like that, which was surprising for me a little bit. But that's how this top 10 links is looking. It looks like. And I didn't find anything useful here, but that's how this placeholder or solution workaround works. And I decided to ask some more general questions to present how it's actually working. The most typical ones, the most painful for everyone, is the VPN question for sure. And I ask how can I connect to the DataArt VPN actually. That's not super powerful because it's an internal project. It's limited in terms of the computing resource. For sure, with the scaling, the performance might be slightly better or even significantly better, depends on the money you would like to invest on your infrastructure, on Azure and stuff. But here is the answer. With all the links, structure it into Markdown that we can render even on Teams. And there's all the links, what you need to do, what kind of user password you need to. As you can see, this following to the Confluence, to the DataArt Confluence. And so all the links are correct. It was validated. So everything's great, looks awesome. Even the email address of the global helpdesk, and even in the same chat, or we can create a separate session to ask more questions. We can provide the feedback, and I'm just asking what was the public holidays in my location, not mentioning location itself, because the bot can retrieve the data, as I have said. This information stored in the PostgreSQL, and we can retrieve this information using just the bot itself. So, and here is the upcoming holidays in Cyprus. As you can see, like the next one in June, great. We have more days off than I expected. So awesome. And I think that's it in terms of the demo session, and that's it in terms of the presentation. Thanks for your attention, and